Welcome back to class. My name's RJ and this is Design for Dynamic Wearables, a course where we take a look at computational design techniques through the lens of body architecture, fashion, and accessory design. So today I wanted to do a quick overview of the plugin for Grasshopper called Peacock. Peacock is a jewelry plugin that focuses on gem setting and ring design. So I wanted to show today a quick overview of how to make this ring. I found this image online and we're going to try to duplicate that today in this workshop. So we'll take a look at how to set up the band size for the ring. We'll also take a look at two different gem settings and prong settings for the floating and the ones on the rail. So let's hop into that. So to begin with Peacock, we'll take a look at the ribbon tab up top and see what components are given to us in this plugin. So we have analysis tools, data sorting tools, display options, which will come in handy at the end of the tutorial, a lot of gem setting options, which we'll use throughout, ways to create different kinds of chains, braids, and jewelry, some production things for producing these with lost wax casting and other sorts of methods, profiles for ring shapes, rings themselves, so we can set sizes and shapes here, and then the workbench has a lot of other tools for certain helpful things during the jewelry design process. So we'll get started with a ring base here, and we'll just use a ring profile, as it's a very simple way to get started with the band shape. We'll first start by plugging in a profile curve. So by default, it's got this profile to it, but I just want to go for something really simple today. So we'll use a rectangle as the curve, and that'll simplify our shape here. So we can control the size of the ring in both width and thickness by these two inputs down at the bottom here. So we can use a slider for this. I'm just going to go 0.1 to 2 to give us some range here, and we'll duplicate to go width and thickness at the same time. So we'll bring this up to something that looks good, 1.5 for the width, and we'll do about 0.6 for the thickness. So we have a pretty skinny band here. We can also set up the ring size using a size to radius component. And with this, we can first start by choosing the region that we're going to be doing our sizing in. We have 5 different options here. Today we'll just go with the American size. So we can use a slider from 0 to 4, which will toggle through all of our 5 different sizes. So we can look at the chart that it gives us here, and if we set this to 3, that'll put it to an American sizing scheme. And then we can set the actual size itself, so we'll do this with integers. I'll just go 0 to 15 here. And then with this set up, we can plug in the same region slider to region, and then the size slider to size, and then set our inputs here. And we're setting it up like this because we'll also want to add an arc that goes around the top of the ring so we can set those top stones as we can see in the reference image. So to do that, we can use a simple arc component, and this will create like a half moon, half circle shape for us. And we'll start on placing this on the XZ plane, so it places it on the same plane that the ring is on. So that lines up. We can give it a radius, and I like the radius to be the radius of the ring plus the offset for the band. So we can add an addition component here to do that measurement for us. So we know the size to radius is giving us the radius of the internal diameter of the band. And then we also have the thickness of the band as well. So we'll add those two together and set those as the radius. So now our green curve is falling on the outer surface of this band. We can also apply an angle to set just how far this curve is going. And we'll think about the ring in 2 quadrants right now, so the left side and the right hand side. Just for this shape, we can model everything on the left and then at the very end mirror it over to complete the ring and fill out the right side. So we'll just focus on setting up the left hand side right now. And for the arc itself, we can set up a domain with construct domain, and we'll look between 0 and pi right now, so 3.14. We can see that the arc by default is 0 to pi, so if we set up a domain that does the same thing, so 0 to 3.14, we can plug that into the angle measurement, and the arc currently is unchanged, but if we pull this slider back from max, we can get the arc to be a lot shorter. And we can use both of these to dial it in to give us a shape that's on the upper left-hand side of this ring. So with this, we'll want to start by adding gems onto this curve. So we can use the Gem Studio component to do that, but it'll take a couple inputs to set this up. First one being the base plane of the gems themselves, right now we have a ring profile and we have the arc, but we'll have to set planes on this curve to get the gems to align to the direction of the curve and also the position where we want to set them. So we can start out by setting the positions with a divide curve component. That'll take our curve and divide it into points. We might not like 10 points, so we can add a slider between 1 and 10 and just hone that in, maybe 5 points for now. And right now we can set a plane to it, but if we set an XY plane, they're all just going to be flat horizontal planes, which isn't aligned to our band. So we'll delete that. We want to actually align it to the band, and we can do that with a surface closest point component. This will insert a surface and a point and give us the UV value of where that point lies. And then we can use an evaluate surface to actually grab the frame for us. So with those in mind, let's wire these together. We'll start by adding the points into the point input, and then we'll need to grab the surface as well. And the B-rep is not a surface, but we can deconstruct this B-rep into its 4 surfaces and then use the surface we want to do this calculation. So we can start by deconstructing the B-rep. So we'll take the ring there, plug it in, and we'll get 4 untrimmed surfaces on the faces output. We can use a list item by plugging in those faces into the list, and then we can use a slider since we have 4 items from 0 to 3 to give us 4 index values, and we can swipe through here and see which index value gives us the top surface, which is going to be 3 in this case. So now that we have a surface, we can plug that into the S value, and now we can get UV coordinates for this surface. So we can take our surface, which is coming from the list item, into the evaluate surface, and now that we have the UV values for that surface, we can also wire that into UV, and now we're getting 5 frames that align perpendicular to the normal of the surface going around the 5 points that we set. So with this, we can use our frames, which are our planes, and plug that into the plane input. Let's hide everything we don't need at this point, so we don't need to see any of this anymore. And now we can see that we have 5 just normal circular stones set up aligned to the curvature of this ring. We can change the shape and the size, so the shape will be what type of stone it is. There's 16 different ones to choose from, and then the size can just be a numerical value. So let's grab ourselves a slider and see which value works for this ring. So the thickness of this ring is 1.5 across. So we can go somewhere close to that, and those stones look pretty good. And we can always come back to the arc itself and hone in on this distance here by changing those 2 sliders. We'll get the stones pretty close together. And once we have those stones set, we can look at another Peacock component called prongs along gem rail. So this will add the prongs on the stones, but keeping in mind that these stones are really close together, so it'll optimize where to place the prongs right in between. So we want to start by fulfilling the girdle input and the plane input. The girdles will come from the Gem Studio. The C output gives us those girdle curves, and we can use the frames for the Gem Studio as the planes for the input here. So there we can see we have prongs coming into view, but they're a little thick right now, so we can add sliders to change these values. We can start by affecting the width and the height of this value. So let's grab ourselves a slider, one for width and one for height. I'm just going between 0 and 1 for these. So let's plug these into width and height, and we'll hone in on the size of them. So the width and the height there. And just make sure if you're producing this ring, you create realistic sizes for these so you can actually bend them over when you are assembling this ring. So keep that in mind. So now that we have these side stones set, let's set this large central stone right on the top of our ring here. So we can start by constructing a point, and we'll use this point just to align our singular stone, and we can affect this point with sliders here. So let's do a decimal, just go up to 30 to give us a lot of range there. And we'll want to change values on Z and Y. So Z will make our point go up, and then Y we'll do -10 to 10 with a decimal there. This will allow our point to go back and forth on top of this ring so we can fully align where this gem should sit. So once we have that, we can copy and paste our Gem Studio component from before, and we'll use this to create our new gem. So as I mentioned before, we have 16 different gem types. So if we grab a slider from 0 to 15, we can use that to select all the different shapes. And if our intention here is to go for a pear shape as seen in the photo, we can go to index number 8, it looks like. So we'll slide this up, we can see all the different shapes. And at 8, we have that pear shape. So right now we have the shape, but we have to put it on the point that we set up here. So we can start out by creating an XY plane on that point. So that'll give us the plane input. So if we plug the plane in, the shape will go to that, but it's not the right direction currently. So we can rotate this plane. So the G input is the geometry we want to rotate, which is the plane. We want to rotate it about the plane itself because we're just rotating on the XY axis. And then we'll need to put in a angle. One thing I like to do is right click on this and just set this to degrees to keep it simple for myself. But up to you if you're more comfortable working in degrees or radians. And we'll just set a slider from -90 to 90 to give us rotation options. With this new plane set up, we can plug that into the Gem Studio. Let's hide everything we don't need. And now we see the gem is pointing in the correct direction for our reference image. We can boost this gem size up. Let's make this slider even bigger so we have more range to work with. And one thing to note is if you want to look for realistic gem sizes, I'll include this link in the file, but this will take you to a website here that'll show you actual gem sizes with their carat weight and their millimeter size. So we can see that if we're aiming for a 1/4 carat, we can go for a 5 millimeter input. If we're going for 1/2 carat, we can do a 6 millimeter input, so on and so forth. So let's shoot for the 1/2 carat version here. So we'll put this right at 6, and that'll give us a tip to bottom diameter of 6 millimeters for this shape. So we have a 1/2 carat pear shape stone setting at this point. And this link also has options for all the different kinds of shapes of stone. So if you're not using a pear shape, if you're using anything different, you can find that there as well. So let's keep moving on. One thing I will point out is if you want the prongs to cap the ends of this line as well, we can also add a toggle component. Set this to true and just plug that into the ends, and this will cap off our curve. Awesome. So at this point, let's set up the halo that goes around the bottom of this pear. So we've got 3 circular gems sitting there and then 1 pear shape in the opposite direction right on the bottom. So let's just duplicate the work that we already did for the first pear, and we'll pull this up, and let's move this stone just behind it. And we can flip the angle around so it points the other direction. And we can also change the size to make it a lot smaller. Looks like it's vaguely in place. So let's finish off this stone. Right now at this horizontal alignment, that might not be the best ergonomically. One thing I did notice in this photo is it looks like most of these stones on the halo are canted down at a slight angle. So we can set that up pretty simply just by creating a normal vector from the midpoint of the ring. If we look at this crosswise to where the gem is sitting up here, and if we set an angle, we can get a plane that's slightly at an angle. So in order to do that, we can use a vector and just do vector 2 point, so we can set a start and an end. We can use the point that we created, which is the construct point, the one that sits right in the middle of this pear, as the end. And we can use the middle of the ring itself, so just the origin point, as the beginning. So the origin point's really easy to do. We can just create a construct point component with no inputs, and that'll create a point right at the origin of your rhino scene. So now I have A and B creating a vector, and instead of creating an XY plane, we can create a plane normal, and this will allow us to give a position input as well as a vector input, and that'll make a plane along that vector. So now it's slightly rotated. So doing that, we can get rid of the XY and the rotate and just go with this plane normal. So now our stone is sitting at that slightly canted angle, and we can change our slider values to set this just a little bit cleaner. Perfect. So now let's set the 3 other stones that wrap around the halo, and we can do that just very simply using a interpolated curve that we can just draw in Rhino. So let's first go into top-down view. This will make it easiest to draw our curve. So let's do the drop-down here and go to interpolate points. And then if you have grid snap turned on, we can turn that off so we can place our point wherever we want. And let's set a curve just with 3 points that wraps around pretty simply like that. That looks good. Right now it is just on the XY plane, so we'll go back into perspective and pull this up to the level of everything else. Looks good. And at this point we can do a very similar method to how we set the initial stones on the band, but let's first bring the curve into Grasshopper. So we can right click, set that curve, and we'll divide the curve again into points. And we just want 3 points on this line here. So let's grab a slider, plug that in, and if we look at Rhino here, a value of 2 will give us 3 points on this line, so it's splitting it twice. And with this, we can set up our plane. We'll just do the plane normal with the vector again, so let's copy that set over. So we have our origin point, which will stay the same origin point for this workflow as well, but we'll use these new points that we just made as the B input, and we'll also need to plug those into the origin of the plane as well. And if we preview this on, we get 3 planes that are now sitting on this curve that we just drew. So with that, we have everything we need to set up another Gem Studio. So we'll copy paste that, and we'll set that into our new planes. So let's hide everything we don't need again. And at this point, we don't want pear-shaped stones on these, we just want the brilliant option. So we can slide this back to 0. That'll give us the brilliant option, and then we can slide this down to choose a better size of stone. And we can always come back in and move this curve around just by hand in Rhino to get the perfect fit for these stones. So at this point, let's set up the prongs to hold all of these new stones into place. So we can start with the large pear shape in the center, and we can start with gallery rails to create a rail underneath this stone to hold it in position, and then we can add the prongs to the rail to actually hold it down. So let's wire this up here. So we have the large centerpiece stone. We can start by adding in the girdle as always and the plane as always that it sits on. That'll create 2 rails for us here, but we only need 1 at this point. So we can come to the distance offset for the rails, and this is how far down it's pushing each rail. And since we only want 1, we can just do a single slider. So let's create that using decimals so we have more resolution here. So let's plug that into distance, and we can slide this down. I'm just going to slide it until it kind of gets in line with the original band that we created. So now we have that shape down there, but we can pull in the width and the offset as well. So let's do that. So the width is going to set our thickness of the curve, and we'll just go something similar to the band itself. And we can set this for the height as well to give us a perfect circle there. And then we can also set the offset, so let's grab another slider for that. And we'll want this to hug the stone, so we'll bring the offset in and just align it to that band there again. So that looks pretty good as it hugs the stone just at the bottom. And we can also set up the prongs for this stone as well. So let's go back up to gems. We can use our prongs function, and this also takes a girdle and a plane. So to make this simple, let's just set up some relays so we can make this a little bit cleaner. First one will be girdle, second one will be plane. And we can wire these same ones into the prong inputs. So this will start to give us some prongs, but we'll need to affect the positioning. So we can use 3 sliders for this. And let's just go between 0 and 1. So I'm going to do a decimal, 0 to 1. And we'll do 3 of these because from the inspiration image we have 3 prongs, 1 at the tip and then 2 down at the bottom here. So let's plug all those into position. So the first one, the second one holding shift on the keyboard. Plug that in, same for the third, hold shift to plug that in. So 0 will be good for the first one, that'll keep the prong at the top. For the second prong, we'll want to put that in a different position. But you can see if we go to 1, it's not going all the way around the stone back to the start yet, which is what I would like. So one thing you can do is come to girdle, right click on that and just reparameterize that. And that'll set the domain of the curve from 0 to 1. So 0 and 1 will both be at this point, and anything in between will be around the curve of the stone. So we can pull that number to around 0.4, and then the other one we can go 0.6, and that'll set the 2 prongs at these bottom positions. And we can also set the width and the height, and we can just use the same slider that had the height from before. And I like to use a data component just to make this cleaner. So we can bring that up, plug that into width and height. That'll make sure our prongs are the same shape as the gallery rail below it. And we can use another slider from 0 to 1 for the shape of these prongs, and you'll see what this will do in a second. As we pull this number up, the prongs will start to curve in under the stone to hug it a little bit better. And we can use another slider to affect how far these prongs go down under the shape. So we can have that align to the gallery rail a little bit better. We might have to make this a larger number so we can pull these in a little bit more, just so we can get the prongs to touch that gallery rail. So that setup looks pretty good. The stone is now fully enclosed in prongs. So we can do this same thing for the other stones in this halo set around the pair. So really nice that we have this now. We can copy the prong and the gallery rail setup. We'll copy that and we'll paste it up here for both the brilliant gems and the small pear shape. And if you do Control-Shift-V, you can just paste it where you're looking in Grasshopper, which is a good tip. So let's go ahead and fulfill these inputs again, first being the girdle, second being the plane. Same for the other one as well. Girdle first and then the plane. And this is copied all of our settings over to these stones as well. But we'll have to edit the size a little bit because right now they're way too big. So we can come down here and change the height. That'll make these prongs a lot skinnier. We can change the offset to bring that in and the distance as well to get that just back onto the stone. And then we can come down and change our settings for the prongs as well, changing the shape and the long B inputs to get those to be good. And then we can do the same for the brilliant shapes as well. So if we were using a height of 0.27, let's do the same here. And we're using an offset of 0.25, so let's copy that over. And a distance of 0.29, so we'll copy that over as well. So that'll put our gallery rails on these stones. Maybe we can move these a little bit more just to get them to have an opening at the bottom there. Looks pretty good. And then again, we can change these settings as well. Just to make sure the prongs don't go into the stone, but are just going around it and then onto that gallery rail. So that looks pretty good. And we could change these parameters a little bit so we go perfectly in thirds around these brilliant stones. So if we want to go in thirds, we could do 0, 0.33, and then 0.66. So instead of 0.4 and 0.6, let's replace that with these numbers. So again, hold shift and we can add the wires in, and that'll just make sure our prongs are perfectly centered around these shapes here. So that looks pretty nice. Last thing we'll have to do is just connect these floating gems back to the stems around the large pear. And the easiest way to do that is we can just draw, let's go back into top view. We can draw a connection just with a polyline from the small stones to the large stone, and we'll just go into the gallery rail for the large stone as well. So let's do that for all 4 of the stones here. That looks pretty good. Now we have all 4 curves. Let's internalize these in Grasshopper by just setting multiple curves, and then we'll go back into perspective and actually move these into place, because again, they're always going to sit on that XY plane. So let's bring these up, and once they're in a relatively good position, we can click on them and actually edit the control points and start putting these curves at an angle if needed. So we can do this to connect any curves together just manually. So these other 3 look pretty good, so we can leave those there. And let's just make a pipe quick to add thickness here. So we'll put those curves in. Let's change the end. You see we have 3 options here: none, flat, or round. So we can use a slider from 0 to 2. And if we want them to be round caps, we can set that to 2 and plug that in, so we get those round caps coming in. Right now the radius is much too large, so we can use the radius that we're using for the prongs themselves. And right now that will be the height value, which is controlling everything. So let's plug that in. Right now the height value in Peacock is getting cut in half automatically, so we only have to plug in 1 number. So we have to do that manually for this one. So we'll just divide by 2, and then we can take this curve and we can use Control Shift on the keyboard to pull it out and plug it into A. Then once that is plugged in, now our radius, or the height value, is cut in half to become our radius value. So now you can see that pipe is now the same thickness as our prongs. So that's pretty well set up. So at this point, let's join everything that are prongs or gallery rails in our scene. So we can use a merge to start collecting those. So we have the pipes, these prongs, these gallery rails, the prongs for the pear, the gallery rails for the pear, and then we'll also need the prongs and gallery rails for the large pear shape. And then we can't forget about the prongs that we made for the stones on the band as well. So let's group all these together. So now we have them as this one merge component here that we can select. So now that we have the parts that we want to add onto our band, so these will all be joined to the band, we'll want to create the parts that we will cut away from the band. So in the gem dropdown, we have this cutter component. What this will do is it'll cut through any shape and give us an opening behind the gem. The gems need to pick up light and bounce it out to have a brilliant look to them, and it's best if we have an opening at the bottom for them to do that. If we just put a plate at the bottom, that's going to get rid of a lot of their shininess and reflectivity, so we can use this cutter to cut that shape into the band. So we'll want to make a cutter for the gems on the band and the large pear that is the centerpiece stone here. So let's bring this over to the original gems on the band here, just with the cutter. And again, just like always, this one needs the gem input and the girdle input. So we have our gem studio here. We have the gem with the G input, and then we have the girdle and the C input. So once we do that, that'll give us this shape here, which will be the diameter of the stone at its largest point, and then it necks down to this smaller diameter here and then pops through the band. So that looks pretty good. Let's just pull this down by itself. We'll duplicate it and we'll do the same thing for the centerpiece stone here. So again, we have the girdle, or the gem first, and then the girdle curve, and that'll give us another cutter for that stem, and now it's in a pear shape rather than a circular shape. So let's collect these in a merge as well, and these will be our subtractor geometry. So we'll use these to cut away. So let's just name these up here. So this will be the subtract, and this set will be the union. So now that we're here, let's use Dendro to do the final meshing of everything. With Dendro, we'll always have to start with a settings component. And this will give us the resolution of our voxel set here. And I've explained this in past videos, so I would go check out some of those to get a better explanation of how Dendro works. But we have B-reps here, and we can convert those into volumes with a mesh to volume. It'll do that mesh calculation for us. And we'll do the same thing for the cutters as well. So we'll need a mesh to volume for both. For the settings, we'll start by creating a slider. I like to go from 0.01 to 1, and this will define the resolution of our final mesh. I like to start at 1. This will give us the lowest resolution, but it'll also calculate the quickest. So we don't risk crashing our computer at 1, but if we put this all the way down to 0, it might take really long to calculate the volume. So we don't want that to start. We want to be simple to start. So let's plug the setting value into both of the S inputs. And we'll take the merges here and plug those into the mesh input for both of these. We'll also want to create another one of these mesh to volumes for the original band itself, which we have here, the ring profile. So that's giving us a closed B-rep. So let's just use a data component to move this along, and this will be the original ring shape. So we can plug that in, and now we have the ring in our hand. So let's zoom out and pull that over to the mesh to volume, and we can plug this in as well. So now we have volume of the ring, the additions, and the subtractions. So let's preview off everything we don't need anymore, which is going to be everything except for our Dendro components. So turn those all off. And now we can start to do the combining. And we'll bring the gems back later, so we don't need to see those currently. So we can start by subtracting the cutters from the band. So we have the band here, so that'll be A. And then we want to remove the B input, so the B will be the cutters. So we'll plug that together, and that'll be removing shapes for us. And then we'll want to add in our union components, so we can use a volume union for that. It's always good to flatten this if we want to combine everything, just to make sure that everything is on the same list. You can see this dotted line is showing us that these components are on different branches of a tree, so they won't combine together, but if we flatten it, then they will all combine together. So we have those unioned, so let's turn off these two, we don't need to see them anymore. And we can see that we're not seeing much except these little boxes around, so our resolution is way too low at this point in time. What we can do is go back to the voxel size slider and drag this down so we get a smaller and smaller decimal value. And as we drag it down, we'll see a lot more detail starting to show up in this ring. So let's go down to just about 0.04 here. That looks pretty high quality. So you can see the band has been cut through where the stones were, and then the prongs have been all added together to form one volume there. So now that we have that, we can do a little bit of smoothing if we like, to get rid of any of the sharp edges from the subtraction. And we can control the iterations here with a slider with integer values. I'm going to go 1 to 20. We can plug that into the I input, which is the iterations of smoothing. And the higher we go on this value, the more we'll smooth it out. So if we go too high, we'll start to lose detail. So parts are going away because it's so smooth. So we'll pull this back, rein it in. Right around 6 or 7 looks good for this. That'll give us a really smooth band. We can convert this back into a mesh with a volume to mesh component. Anytime we do this, we also need settings to plug in here. I like to create a new settings component, and I like to set the adaptivity here to 0.01, and this will just give us a much higher resolution of the mesh, of the final mesh. So let's wire this up. So now we have a mesh coming out of here, a final mesh, 100,000 faces. And last thing, let's just cut this in half and mirror it over so the right side is the same as the left side. We can do that with pufferfish with a mirror cut mesh. And we know we want to mirror on the YZ plane, so on this green axis here. So we can type in YZ, get that plane for the mirror operation. And then we can plug our mesh into the mesh input. If we turn off this, we can now see the right side mirrors the left side perfectly. One thing I like to do as well is come down to this bulge value and just set this to 0. Negative 0.5 is going to give some issues, like we can see at the intersection there, and then also here we can see that. But if we plug in 0, those issues will go away, and we'll have a much cleaner join at those intersections. So now we have a left and a right side of this band. So let's bring the gems back into this as well. So we didn't collect the gems yet, so let's go through and do that. So let's turn these back on so we can see all of our gems. So let's take the ones that we want to mirror and merge those together. So we want to mirror these. We don't want to mirror this one because it's in the center. So we'll come back to that. We don't want to mirror this one either because it's in the center. We do want to mirror these. So we'll pull those two together. And let's merge the center stones as well. So here's a center stone. And then the other center stone is right here. So we'll merge those. So now we have a set of stones and then a set of stones to mirror. So let's name those up. So let's do the mirror for those stones. And again, we'll want to mirror on the YZ plane, which by default looks like that's how it's set up. So let's plug that in. And now we can do a final merge and collect everything. So the stones that are good to go, the original left-hand stones, and then the new right-hand stones. So let's turn everything off again that we don't need. And we're just left with this merge with all the stones on it. So let's create a component for final stones. Pull that over, and then another data block for the ring metal itself. Turn everything off we don't need. Now I have the ring here and the stones here. So the final thing we can do to finish it off and make it look like the initial image that I showed in Rhino is we can bake the stones. Let's group them into Rhino, and we can bake the ring itself. Let's group that as well. And we can close this panel for the moment. We can come back to Rhino and let's put these parts on different layers. So we'll put the band here on layer 5, and we can put the stones just here on layer 4, just on different layers. And we can set up the material for the band and the stone. So for the band, let's go with a metal here. Take the roughness down just a little bit. And for the stones, let's just go with something we can see, which plastic will allow us to see it pretty well. We'll just set the color here. Let's just go somewhere black so we can see it pretty well. And at this point, we can go into rendered view to see the final metal and the final stones. And now it looks pretty good. So we've got the silver metal, we've got the black stones, all set up, looking pretty clean. So that's the process. Very simple for using Peacock to create a ring. And we're just creating this bottom band here. We didn't get to the top one yet. You'll have to create a custom band for that. We can't use a preset, but maybe we'll do that in the future if there's enough requests for it. So hopefully that was helpful. As always, the project files for this workshop are going to be in Patreon, so you can go download the Grasshopper and the Rhino files there. I'll put a link to the Peacock plugin in the description. And as always, if you've got questions, comments, or requests, put those in the comments as well, or we can talk more on Patreon. So with that, hope that was helpful, and I'll see you next class. Bye.